Welcome back. Chapter 5 Elementary Probability Theory, Section 5.2 Some Probability Rules, Compound Events. The focus points in this particular section are compute probabilities of general compound events, compute probabilities involving independent events or mutually exclusive events. Use survey results to compute conditional probabilities. Okay, let's see what these are. First, conditional probability and multiplication rules. Independent events. Two events are independent if the occurrence or non-occurrence of one event does not change the probability that the other event will occur. Okay, so repeat, two events are independent if the occurrence or non-occurrence of one event does not change the probability that the other event will occur. There is a multiplication rule for independent events. Probability of A and B is probability of A times probability of B. So what does this mean? Probability that both A and B occur is given by probability of A times probability of B. So this happens if A and B are independent. Conditional probability. If the events are dependent, then we must take into account the changes in the probability of one event caused by the occurrence of the other. Okay? Sometimes one event influences the occurrence of the other. So, probability of A given B, that vertical line is red given. The notation P of A given B denotes the probability that event A will occur given that event B has occurred. This is called conditional probability. We read P of A given B as the probability of A given B. If A and B are dependent events, then probability of A is not the same as probability of A given B, because the occurrence of event B has changed the probability that event A will occur. Now, a standard notation for probability of A given B is P of A vertical line B. So given B is this line B. What is the general multiplication rule for any events? Probability of A and B is probability of A times probability B given A. So A has occurred and then you're looking for probability B will occur given probability A. Another way of thinking of it is pretend probability of B has occurred, then you're looking for A given B. So they are both, this is equal to this, which is in turn equal to this. All right. Now, multiplication rules for probability. We will use either formula 5 or formula 6 according to the information available. So 5 is this, 6 is this. All right. Formulas 4, 5 and 6 constitute the multiplication rules of probability. They help us compute the probability of events happening together when the sample space is too large for convenient reference or when it's not completely known. Okay. For conditional probability, observe the multiplication rule. P of A and B. Probability of A and B is probability B. So B has finished, B has occurred, times probability of A given probability of B. So this tells me I can solve for probability of A given B, divide both sides by probability of B. So probability of A given B is probability of A and B over probability of B. Okay. This of course makes sense when the denominator is not 0. Here is an example. Suppose you are going to throw 2 fair dice. What is the probability of getting a 5 on each die? Well, the 2 events are independent because if I throw 1 die, it doesn't impact the second die. So 5 on the first and 5 on the second. So probability of 5 on the first and 5 on the second. So that is independent. So you have probability of 5 on the first times probability of 5 on the second. Well, to finish the problem, we need to compute the probability of getting a 5 when we throw 1 die. There are 6 faces on a die, and on a fair die, each is equally likely to come up when you throw the die. Only one face has 5 dots. So we get probability of 5 on a die is 1 over 6. So probability of 5 on first die and 5 on second die is probability 5 on first times probability of 5 on second, which is 1 over 6 times 1 over 6. That is 1 over 36. Here is another approach using sample space. The first task is to write down the sample space. So you have the first die, second die, first die, second die. So first die, pretend you got 1. Second die, you have all these different options. 1 or 2 or 3 or 4 or 5 or 6. Likewise, next, pretend first die got 2. Then second die has all these options and so on. You are looking for that one option which is 5 and 5 on both first and second die. How many outcomes are here? So this is first outcome, second outcome, third outcome, so on. There are 36 outcomes in all. 1, 2, 3, 4, 5, 6, right? 6 rows and 6 columns. 1, 2, 3, 4, 5, 6. So there are 36 outcomes, out of which we are looking for only 1. So probability of 5 on the first and probability of 5 on the second is 1 out of 36. Both the methods gave us the same result. All right. So which brings us to how to use multiplication rules. First, determine whether A and B are independent events. If probability of A is same as probability of A given B, then the events are independent. That is, occurrence of B did not impact probability of A. It continued to be the same, equal. If A and B are independent events, then probability of A and B is probability of A times probability of B. If A and B are any events, then probability of A and B is probability of A, so A has occurred, times probability of B given A has occurred, which is same as, suppose B has occurred, so probability of B times probability A given B. All right, which brings us to addition rules. So we'll come to addition rules in our next video. Until then, bye.